Good morning, guys. Today, what we're looking at in this lesson in Chapter 6 is the environment and change over time, okay? It's a really great chapter. We cover a lot of objectives in the Alabama Course of Study, and it looks at fossils. What are they? How do we determine fossils? How are they made? And then we look at the concepts of natural selection and evolution and how we came to be where we are today and how other animals came to be where we are today. And we look at how there are certain traits that have survived over time and ones that have not and why. Okay. What we're going to do today is we're going to look at lesson 1 in chapter 6. You this is going to be kind of tricky or different in January in the fact that we're doing a staggered schedule. So Monday and Tuesday, what we're going to be doing is we're going to be doing the lecture, going over the PowerPoint, talking about the material and everything, and then doing the same thing on Thursday, Friday. So if you are absent a day, you just need to click on the video. The PowerPoint will be there on Schoology that you can catch up. Okay. Also, if you've got any questions or whatnot, you can, on Wednesdays, 1 to 2 p.m. is when you can Zoom with me if you have questions or need to talk to me on Wednesdays. You can also, of course, email me anytime, but I'll be especially answering emails between 1 and 2 p.m. on Wednesdays. So if you do have questions or whatnot, email me, Zoom with me then, or email me anytime and I'll answer them, or ask me in class. Anyway, so what we're looking at is the environment and change over time. Lesson 1 talks about fossil evidence of evolution. Okay, we're going to look at how fossils form, how scientists date fossils, and how are fossils evidence of biological evolution. Now, I'm not going to show the videos in this, but you do need to watch them. They're really great, and they give you a good overview. Like this one gives you a good overview of what we're going to talk about and what's in this lesson, and others give you a good wrap-up, or they explain concepts in a little more detail, or lots of times maybe you don't understand how I'm saying it. So in watching the video, you get a better understanding of what I'm talking about. So please watch the videos. Most of them are very, I put them there for a reason. So please watch them. All right, the fossil record. Species tend to change over time. All right, and fossils, the term fossils refers to the remains or evidence of once living organisms. All right, they're not living anymore, they're dead, right? The fossil record is made up of all the fossils ever discovered on Earth, and it provides evidence that species have changed over time. All right. When an animal or organism dies, usually only the hard parts remain, okay, like bones, shells, teeth. The soft parts like tissue decay or break down. Think of like when, police find skeletal remains of a body. Okay, all the skin and everything, after so long, the skin and all the soft parts, it rots away, it decays. And so, they'll find the skeleton, and that's it, the skeletal remains, the teeth, and that's all that's left are the hard parts. Okay. There are 5 ways that fossils can form. They're mineralization, carbonization, molds and casts, trace fossils, and original material. Okay, and we're going to look at each of these. All right, mineralization happens. It's a body fossil. Okay, it fossilizes the body of an organism. All right, and when an organism dies and gets buried under mud or sand in a river or stream, this is when mineralization happens. A fish dies and it floats down to the very bottom of the river. Okay, and it gets kind of buried in the sand and the mud, and the minerals in the water seep in and eventually replace the organism's material. The tissues and everything, and the bones and whatnot are into what I'm trying to say, the minerals seep in and help to fossilize or harden those bones and everything into rock. Okay, and that forms a fossil. Okay, most mineralized fossils are of shell or bone, but they can also be of wood, if you've ever heard of petrified wood. That's a wood like a tree falls in the river, and over time the water seeps in, and the minerals in the water help to fossilize or turn the wood into stone. Okay, excuse me. Uh, Mineralization can help preserve the internal structures of an organism. Okay, because it does seep in to everything and helps to fossilize all of it. All right, carbonization. Fossils form when dead organisms are compressed over time and pressure drives off the organism's liquid and gases. Think about plants or a an organism that dies, and dirt and everything, rock gets, it gets kind of buried in the ground, and rock forms on top of it, and it just keeps getting, the weight of what keeps piling on top of it, just it forms a lot of pressure, and it presses down, that organism presses between all that dirt and rock and everything, and it presses out all the air, the liquid, the gases, anything else, and what's left is just this basic organic material, which is in its basic form carbon. Okay, and so eventually all that's left after that intense, and we're talking intense pressurization, is that carbon outline. Okay, and it's usually kind of black or brown. Okay, and you're going to see, and you see that outline in rock, like the picture there of that plant material. That's a carbon outline of plant that over millions of years was, just pressed and pressed into that rock between layers of rock. All right. Next one, molds and casts. Okay, these can be body and trace fossils. All right. When an organism dies and its shell or bone makes an impression in the sand or mud, that's when you get molds or casts. Okay. What happens is, they're like, if you look at the little molds, the mold and casts, the pictures there, a shell lays in some mud. Okay, and then you pick the shell up. Okay, or you leave the shell there, and eventually that shell breaks down, but that mold, the impression it left in that mud stays, just like a footprint in mud will stay. The foot's long gone, but the footprint will stay. That's an impression. Okay, that's a mold. Okay, a cast is when, like, let's say a shell, like a snail shell, is put in, it's there in the mud and it gets covered up on top, okay? And eventually, it's surrounded by mud, okay? And that mud hardens, all right? Well, that shell eventually breaks down. Okay, but the hardened mud around that shell, even though the shell's broken down, it still made that cast of that shell. And that mud turns to rock, turns to stone, it fossilizes. So then you get a cast of that shell. Okay, the thing with molds and casts is that they only show external features. They don't show what was inside the shell. Okay, they only show the shell itself or the footprint. They don't show what was inside the foot. They show just the print of it. All right, trace fossils. Footprints are trace fossils, okay? It's evidence of an organism's behavior or movement that can be preserved in rock. Footprints, okay, are good examples of trace fossils. Okay, you can see where an animal has been, where it goes. And these trace fossils can get, the dirt, the mud that is left in becomes fossilized, and there you've got footprints. All right, original material. All right, this is another type of body fossil. All right, a lot of original can be preserved. Get that out of there. Think about, everyone should have heard of like woolly mammoths. They're the kind of the ancestors of the elephant, so to speak. And particularly during the Ice Age, like woolly mammoths would. There have been several examples where they fell into deep ravines, these ice, crevices, and they were kind of frozen. frozen in time. And we found them, later in later years in this century or last century, found these huge woolly mammoths that were frozen in huge blocks of ice. Of course, they're dead, but everything about them was frozen. It's just like they were stuck in a big freezer. So all their internal organs, all their, tissue, their skin, everything, the hair on them, it was all frozen. So you've got the entire species right there. Okay, saber-toothed tigers that fell into tar pits. I don't know if you've ever heard of the little Brea tar pits out in California. These huge pits of tar and where animals would fall into for whatever reason, get stuck in, and the tar would kind of preserve that specimen, that organism, and all aspects of it. So it's not just the bones, it's not just the hard parts that are preserved, or nothing's just turned to stone. It's all there as it originally was, just either frozen or preserved. Also talking about insects, tree sap. Tree sap is very sticky. I don't know if you've ever felt it or it's gotten on you. It's very sticky, and like insects, will land on trees or whatnot and get trapped in that tree sap. And more tree sap will come around, and they kind of get encased in that tree sap, and that tree sap will harden. And when it hardens and it fossilizes, it becomes what's called amber. Okay, and so there have been insects, and entire insects that you can extract DNA from that have been found encased in amber. All right, humans have been found fossilized in this manner in bogs. Bogs are kind of wetlands that kind of like swampy areas that accumulate dead plant material, peat. It's very rich in minerals, and so they're very good areas for preserving organisms. And so there have been humans that have been found that have been fossilized in bogs, and we're fixing to, in this next slide, let me move over. There's a picture of a bog man, so to speak. He was fossilized in a bog. They figured out in doing research he had been murdered. You see the rope around his neck, and thrown in the bog. Well, the bog helped to preserve his body. I mean, you can even see the wrinkles on his skin. All of that, everything about him was fossilized. So, even his hat and his hair, his fingernails, everything. So it was really kind of cool. All right, determining a fossil's age. How can you tell how old a fossil is? Well, most of the time, scientists cannot really directly date the fossil itself. But what they can do is they can date the rocks around the fossils. Okay, and they do this in two ways: relative age dating and absolute age dating. Okay. Relative age dating helps scientists determine the relative order of when a species appeared on Earth. And we all know that the deeper you go in the earth, the older the dirt is, basically, right? So if you look at this, this diagram here, the fossils that are at the top are younger than the ones down at the very bottom, right? Because the ones down at the very bottom came first because that's the oldest dirt, right? The newer dirt gets put on top. The newer rock gets put on top. Okay. Yeah, and think about relative order. Like if you're trying to describe the relative location of your house, you're going to say, well, it's the third house on the right past the old oak tree. That's the relative location of it. Okay, so we're kind of given the relative order. Well, this was deeper down in the dirt than this one, so it's older than this one. That's a relative order. Okay. The second way they determine the fossil's age is absolute age dating, and it is more precise. Think of like if you gave the absolute location of your house, instead of saying it's the third house on the right, you would give the latitude and longitude. You'd have the precise exact location. It is at this latitude, this longitude, so that you could pinpoint it with a satellite kind of thing. That's absolute as opposed to relative. Okay, so absolute age dating gives a very more precise age to the rock. Now remember, we're still doing the rock because you can't really you can't date fossils, but you can date the rock around them, okay? And they do this through by using radioactive decay. And radioactive decay uses isotopes to help date the rock and the dirt and everything, okay? And with radioactive decay, unstable isotopes in the rocks, in the atoms that make up the rock, over time change to stable isotopes. And it takes so long to change unstable to stable. And so, you know, they can use these isotopes, they can use these atoms to help date that rock as they can look at what point are these isotopes in the transition process from changing to unstable to stable. It takes 3 million years. I'm just throwing out a number, okay, for an unstable isotope to change to a stable isotope, okay? Well, it's halfway done. It's halfway there. So it must be 1.5 million years old, kind of thing, okay? That's it in a nutshell, all right? Radioactive decay is best measured in igneous rocks. All right, and remember, igneous rocks is formed from volcanic magma. Y'all should have learned that back in 6th grade. But of course, they can be used in metamorphic and sedimentary as well, but igneous is where it's best measured in. So we've got relative and absolute age dating, which determines a fossil's age. We've got the various types of fossils, right? Carbonization, let's go back quickly, make sure I've got them all. Well, here we go. Mineralization, carbonization, molds and casts, trace fossils and original material. All right, so that's how fossils are formed, how they're dated, absolute and relative age dating. And, okay, yeah, okay. And now we're going to look at fossils over time, okay? The oldest known fossils that are visible to the naked eye, you don't have to use a microscope to see them, are 565 million years old. All right, that's old. The geologic time scale, okay, is a chart that divides Earth's history into different time units. All right, think about how we've got years, months, weeks, days, hours, minutes, seconds. Well, that's kind of, you know, the same concept. How we divide Earth's history. We've got eons, which are largest, eras, periods, epochs, ages. Okay. The Earth's history is divided into 4 eons and subdivided into 3 eras, okay? And scientists use fossils to mark these boundaries in the geologic time scale, okay? If you look at this right here, this little picture, we've got, you know, eons, eras, 3 eras we've got, and then our periods, like our Jurassic period. And then we go into epochs and ages. Think of like the Ice Age, you know, Industrial Age. We've got those ages that you know, come about. All right. We can't talk about fossils and evolution and natural selection, all that, without talking about extinction. What is it? Okay, what exactly is extinction? Okay, extinction is when something disappears. Okay. The sudden disappearance of fossils and rock layers are evidence of extinction events. And now, you know, we think of, and it doesn't happen in a matter of days, okay? I mean, you got to think about our history, you know, we're billions of years old. So a few million years is when an entire species dies out, or many species die out within a few million years. That's a big deal. Think about it like if you had a year. Think about like 2020, and in 1 week of 2020, you had all the cows in the world die. You'd be saying, something's going on here. Something big happened that week. Okay, so, you know, you got to kind of, you got to measure time in that aspect of kind of like, you know, a million years would be that 1 week in relationship to a year. A year to 1 week to a year, as in a few million years to our billions of years that the Earth has been on, you know, has been in existence. So, you know, an extinction occurs when the last individual organism of a species dies. And there's no more, that species is extinct. Mass extinction occurs when many species become extinct within a few million years. Like I said, like if all the cows and horses or, several species died off within a week of 1 year, you'd say, yeah, something went on. Something big happened to cause that. It just didn't happen naturally. It was some big major event. Something happened. All right. Well, what causes extinctions? Well, the most simplest answer is environmental changes. Things happened to where something happened to that organism's environment that it could not adapt to, okay, quick enough. Like when their food is altered, their food source or their shelter source or the temperature. You got to think about it. If all of a sudden, trying to think, something that lives in very hot temperatures was put in very cold temperatures, they would not, they would not necessarily be able to easily adapt and survive, and probably most of that species would die off, if not all. Okay. Sometimes these environmental changes happen very suddenly, like volcanic eruptions can cause, environmental changes that can bring about the extinction of a species. Meteoric impacts, that's kind of what they think took out the dinosaurs, because it caused drastic temperature changes. It affected the weather. It put a lot of dust and dirt and everything in the air, and that caused a lot of changes. With all that dust and dirt, all the sun's heat all of it did not come make it through the atmosphere down to Earth, so it cooled off drastically. Things like that happen. And then also gradual changes, like tectonic plate movement can form mountains or oceans, which isolate a species and cause sea level changes. The sea can rise, and so can take away that species' living environment. If the sea level rises 3-4 feet, then there's a lot of land that was lost to the sea that, animals were living on. Land animals were living on that can no longer live. So, there are things like that can happen. All right. Well, how do new species arise? Well, we know how species become extinct. Well, how do new species come about? Okay. Well, over time, scientists began to notice patterns or changes or similarities in the fossil record. Okay, they noticed that there are some previous animals that were extinct, or ancestors that had a lot of similar characteristics to animals that were living now. Okay, but they weren't exactly the same, but they had a lot of similar characteristics. Think about grandparents. You may have you're not exactly the same as your grandparents, but you probably have some similar characteristics. Maybe you have the same eyes or the same nose. Okay. Okay. This is called biological evolution. Okay. It's the change over time in populations of related organisms. And I say, kind of using grandparents and you as an example, but we're talking about, like an entire population of like humans, a whole human species, or all horses, or all cows, or, all dinosaurs, or whatever. Okay. Fossils kind of show this change in a species, and so show what species certain organisms are descended from. Okay, if you look at this diagram right here, they were able to, by looking at the similarities, kind of concluded that horses kind of came from this, way back when, kind of originated or branched off of, or kind of came from this animal. Okay, you've got your horse, you got your parents, you got your grandparents, your great-grandparents, your great-great-grandparents. Okay, kind of, they were able to kind of date back and look and see, okay, well, yeah, this is, they're related. They're not exactly alike. And this little guy right here, there are probably other, lots of other maybe species that kind of, are related to this little guy down here. Okay, they had some similar characteristics. Not exactly alike, but similar. So, yeah, they're related. They kind of, came from that animal, if that makes sense. Okay, I'm hoping I'm explaining this. If not, please email me or, Zoom with me and ask me questions and tell me you got to explain it better. Okay. All right, please watch this, because this does really help explain it as well. This little PBS is 12 minutes. Y'all can do it for 12 minutes. All right, so, ooh, where? Uh-oh, okay. We're missing, sorry guys, I'm missing a, uh, a slide there. All right, so we looked at how fossils formed, right? The 5 times the mineralization, carbonization, the trace, the body, casts and molds. We looked at how they date, how scientists date fossils with absolute and relative age dating, and we looked at how fossils, how are fossils evidence of biological evolution. Okay, how we can look and see how fossils have characteristics and how, you know, we can trace how they evolved, how certain animals evolved over time to be what they are now. Okay, so tomorrow what we're going to look at, let me get back down here, we're going to look at lesson 2, which talks about the theory of evolution by natural selection, and we are going to, where is lesson 3? Sorry. Um, okay, we're going to look at lesson 3, biological evidence of evolution. Something's wrong with this PowerPoint. I've got to figure it out. But anyway, all right, so just make sure you fill out your notes pages. If you've got any questions, email me or Zoom with me or whatnot. Otherwise, I will just see you tomorrow. Bye.